Hi all, welcome back to our YouTube channel. Topic that we have today is from FRM Level 2 and it's from paper 1, that is market risk, and topic is volatility smiles. Very interesting one. And yes, please do subscribe to our channel. It takes a lot of efforts to come up with videos like this. And yes, we try to make you think and stimulate your thought process, which can enhance your learning process. So this was a question that was asked today in one of the forums. So a market maker on FX desk, so an investment bank has been asked to provide code for FX call option, which expires in 7 months. So there is a market maker or a trader, you can say, for sake of understanding, and he has been asked to provide code for FX call option, which will expire in 7 months. So to price this, you will need, of course, volatility. The option has strike price of K and the spot price of S0, and ratio of S over K is 1.075. The market maker reference following implied volatility surface. So usually it happens that you get implied vol surface from the market. And so like usually if you see that time over here is 1 month, 3 months, 6 months, and 12 months, and something that you're looking for is 12 months, and ratio that's uh, over here it's strike to spot, so it's K over S, so basically it's moneyness. And similarly, like the numbers that you're trying to looking for are not part of the table, so in this case it's 1.075, which lies between these two numbers. And the timeline that you're looking for is something that lies in between these two numbers. So basically what we'll do, we will try to use this data over here and over here. So you can think of this as, let me call time as X because it's most independent variable. This is your Y, and you have been asked to calculate some Z which lies in between these numbers. See, when it comes to two-dimensional figure, if this would have been two-dimensional data, it's quite straightforward, calculate slope and take the data. But I mean, when it comes to three-dimensional data, something like this, then it's bit of challenge. So what we'll do, so you can explore plotting these kind of data in Python, because see, I mean, for calculation perspective, exam perspective is quite straightforward. I'll help you out with the process. But I mean, if you really want to work with these kind of players, then you need to get more sense of data. In fact, trust me, I mean, highly unlikely that this kind of question may be asked in the exam. But yeah, I mean, for initial learning process, it is also good to understand how interpolation is done in this kind of data. So let's see. So this is something which like you are asked for 7 month and moneyness of 1.075. So what we'll do, basically our final objective is to calculate Y3. But what we will do, please be careful. Step 1 is to calculate Y1, in which basically what we'll do, we will keep this 6 constant, that is 6 months constant. We will try to move from moneyness of 1.05 to 1.11, and we will try what is Y1. Similarly, we will do this for 1 year time point, that is wherein your 1.05 moneyness is 9.55 and 1.1 moneyness is 9.75. I mean, it's volatility, of course, and it's percentage. So first we will try to keep, like, essentially we are doing it like a two-dimensional data, wherein you are just thinking that your two coordinates are this and this and this and this, and another set of data you will believe that 1.05 and 9.55, 1.11 and 9.75. You will get Y1 and Y2. Now, now what you will do in third step, you will keep 1.075 constant, and you will check if I move from 6 to 12 months, how my like Y3 should be. I mean, if I move from Y1 to Y3 and your time is moving from 6 to 12, what should be your Y3? That's the process. Calculate Y1, calculate Y2, and calculate Y3. Let's see how we calculate Y1. So Y1 would be, the starting point is 9.1. So that's the basic seed, I would say. So from here you will start walking. So you are going from 9.1 to 9.45. And so this is your, you can say this is your x coordinate, and y coordinate is changing from 1.05 to 1.1. So change in x, so you can think of this as delta x and divide by your change in y. This is your kind of a slope, but this is your total slope, but how much you are trying to move. You're trying to move from, uh, it's like you're trying to move from 1 point. So you're basically, I think, just give me a minute, I think it should be 1.05 minus 1.05. Just give me a moment. Let me check my working. Yeah, it should be 1.0, because see what essentially I'm trying to do. If I'm walking from 1.05 to 1.1, this is a change in 9.1 to 9.45. What would be changed if I move from 1.05 to 1.075? So this number, this quantity would be 1.05 minus 1.05. So what is the change in 9.1 if I move from 1.05 to 1.075? That's how it can be interpreted. There was a typo error. I'll get it correct, but I would imagine this to be correct. Similarly, what you will do, you will try to calculate what initial seed, when you are at 1 year, your initial seed value is 9.55. So when you are moving from 9.55 to 9.75, your corresponding change in value of y is this. So 9.75 minus 9.55, 1.1 minus 1.05. And in similar way, it should be 1.0575 minus 1.05. You can just try calculating. If there is any error, please do comment in the comment box. Now you have got this y1 and y2. So it's 9.275. Just write it as 9.275, and this one is 9.65. So basically now if we are moving from time half year to 1 year, my volatility is changing from 9.27% to 9.65. What should be for 7 months? That's how it can be thought of. So initial value is 9.275, and the total change is 9.65 minus 9.275 when you're changing by half year. And the total change I'm looking for is just 1 month. I'm looking that what would be change if I move from 6 to 7 months. So you will just multiply with this and your value would be 9.34. So correct answer for this is C, that's 9.34%. And if you still just verify the calculation, I think there was a typo error by the team. So just verify it. If there are any mistakes, you can always comment in the comment box. And as I said that from learning point of view, try to understand this data visualization. This is more important as a FRM candidate rather than this calculation part. Trust me, just with the one line of code, you can directly get 9.35. There is no need to, in practical, what I'm talking about, there is no need to do all this calculation. But yeah, I mean, eventually you should always be clear with fundamentals, what at a backend the script, Python script is doing. So it's to just to give you sense of that. So yeah, this was for today's video, and hope you liked it. And if yes, please do subscribe to our channel, like, comment. And yes, I mean, we try encouraging you to think. That's our main target. That's our main motive, to make you think, which can help you in exam to crack it. So yeah, stay connected with the channel, and thank you for staying till the end of the video.